Okay, welcome to this video where we're going to be covering a load of the topics that haven't yet appeared on paper 1 and 2. Now you can see within this paper there's going to be quite a lot of the topics that haven't appeared, but obviously it's impossible to cover all of them. So obviously on the channel I've already posted a video that goes over one question on each of the topics within this list, but for this one we are going to do an exam style paper. So obviously there is a lot to get through, but do check out the videos that I've already posted, and with that being said, let's get started. Okay, so as with all of these videos, you can access this paper by scanning the QR code on the front. It'll bring you back to this video at any point. But getting started with the paper. So question 1, we're asked to find the lowest common multiple. So when we're finding the lowest common multiple, we just need to draw a table, write out some of their times tables and find that first match. Now when a number ends in a 0, like the 40 does, we know that our lowest common multiple will have to end in a 0. So it's worth starting with the 56. Now all I'm going to do on the calculator is just type in 56 plus 56, which is 112, and just keep adding 56. I'm going to write this out until I get something that ends in a 0. So I'm just going to keep on going. Sometimes you have to go for quite a while, but I've just landed on 280. Now I already know that 40 goes up to 280, but I'm going to write some of them out just to make it really clear. I know what I'm doing. Depending on how many I had to write, if it was like a list of 50 or something I'd have to write, clearly you wouldn't want to be writing those down, but 280 is our lowest common multiple there, so there's our final answer. For part B here, we're asked to find the highest common factor of these two numbers, and they're both written as a product of prime factors. There are two methods that you can do to go about doing this. We can type those numbers in, so 2 cubed times 3 times 5, that's the number 120, and 2 squared times 3 times 5 squared is the number 300. You can then find the highest common factor of those using a normal table method. So I'll find the smaller number, so 1 and 120, 2 and 60, and if you get to this point where you spot that there's a factor that goes into both, you can stop right there, so the highest common factor is 60. When it's written as a product of prime factors though, you can match up what's in both. So they both have a 2 squared in. A has a 2 cubed, but they both have 2 squared. They both have a 3, and they both have a 5. If you multiply those all together, you'll get the highest common factor. So we get a highest common factor of 60. And there's question 1. Question 2, we have averages from a table. It's asking us to estimate the mean. When estimating the mean, you have to find the midpoints of those groups, or those class widths. So from 5 to 10, the midpoint is 7.5. 10 to 15 is 12.5. We can carry on a bit of a pattern here, so 17.5 and 22.5. We then multiply those by the frequency. Don't forget you have a calculator, but 1 times 7.5 is 7.5, 2 times 12.5 is 25. I'm going to use my calculator now. So 17.5 times 7 is 122.5. And 22.5 multiplied by 8 is 180. Now that's the estimated total for each of those rows. So if we add them all up, we'll have the estimated total for everybody. So plus 25 plus 122.5 plus 180. Double check you've typed those into the calculator correctly, and that adds up to 335. So that's the total for everybody, and 335. And it says in the question that there are 18 students, but of course we could find that from the total frequency. So if the total is 335 and there are 18 students, we can do 335 divided by 18 on the calculator, and we'll get the answer 18.61, the ones recurring. It wants our answer correct to 3 significant figures. So 1, 2, 3, that chops it off after the first decimal place. So 1 after the line, so my answer would be 18.6. So the final answer for that question is 18.6 seconds. Okay, on to question 3. Now in this question we've got some parallel lines. It says A, B, C and D, E, F are parallel lines as shown by these arrows. So we need to find a way of getting the size of angle X, which is just here. Now that's within a triangle, so hopefully we can find the other two angles in the triangle, and it does say give a reason for each stage of your working. So the first thing I've spotted is that we have angles on a straight line just here. And that's one of the missing angles in the triangle. So what we have there at the moment is 110 and 25. If we add those two together, we have 135 degrees. Angles on a straight line add up to 180, so 180 minus 135 gives us an angle of 45 degrees. And that's the first missing angle in the triangle. It says give a reason for each stage of your working, so at this point I would say angles on a straight line add up to 180 degrees. So let's write that down. There we go, angles on a straight line add up to 180 degrees. Now we need to think about, can we apply any parallel line rules? So if we have a look, this is the line that connects both of the parallel lines. So I can make an alternate angle on one of these sides. If I go to the right, I can make an alternate angle with this 110. Likewise, if I go to the left, I can make an alternate angle with these two. It doesn't really matter which one you go for, I'm just going to go to the original one, which is to the right, and down here to the left. So this total angle here is the same as this angle here, and that's 110. Part of this angle is already given to us where we have the 35. So to find just this part here, I would want to do 110, which is the total of the two angles there, take away the 35. If we work that out, I'm just going to type it in on a calculator just to make sure we get it right, and that is 75 degrees, so that's 75. Before I move on to find the missing angle in the triangle, I just need to say here alternate angles are equal. So alternate angles are equal. I can now finish the question because I can find the missing angle in the triangle. So if we add together the angles we have, 75 plus 45, that adds up to 120. And therefore our missing angle would be 180 minus the 120, and that would be 60 degrees. I would want to give my reason for that as well, and that's because angles in a triangle add up to 180. There we go, so write that down. Add up to 180 degrees. And there we go, that's it. So there we go, there is our first question on parallel lines and angles in this one, and there we go, making sure we write down all of our reasoning for those because that's where we get the bulk of the marks on these questions. So on to our next one. ABC is a right angled triangle. Calculate the length of AB and give your answer to two decimal places. Now AB is this angle just here, this side just here, which is opposite the angle. So that's the opposite. Here we're going to be using SOHCAHTOA as we've been given one angle and one side in a right angled triangle. So we'll label this one as well, which is the hypotenuse. Whichever method you use, I'm going to use a formula triangle method for those that use them. SOH is my first one I'd write down, and this has the O and the H in, so I'm going to be using sine. To find the length of the opposite, we cover up the O, and then you just multiply the angle with sine, so sine 38, it will open the bracket, so don't forget to close it, and multiply that by the hypotenuse, which is 16. Type that in on the calculator, sine 38 multiplied by 16, and we get 9.85058 and a few more decimals, but it only wants my answer to two decimal places. So I'm going to chop it after the second decimal. It's a 0 after that, so it would just be 9.85. And there we go, there's my final answer, using some SOHCAHTOA to find a side length. Okay, so question 5. We've got some exchange rates here, and it's also asking us which is better value. Now these questions where they're blended together always look quite difficult, but as long as we get everything in the same units, it makes it a lot simpler. So decide on which units we're going to go for. It makes sense that we go for pounds and we go for litres. So looking at the first one, we can convert the 27 euros into pounds. Now the exchange rate we've been given is €1 is equal to 0.85 pounds. So the pounds number is going to be smaller. So for this one here, we're going to have to multiply by 0.85 to ensure we get that smaller value. 27 times 0.85 is £22.95. Now that means in France you get 18 litres of petrol for £22.95. I'm going to write that down here. So in France we get 18 litres and that is £22.95. Now the other option is in Wales. It says, in Wales, Argent pays £40.80 for 8 gallons of the same type of petrol. Now that's already in pounds, but this is written in gallons. But it says that 1 gallon is 4.5 litres in this second conversion just here. So if we want to convert that into litres, we get more litres than you do for gallons in terms of the size of the number, multiply it by 4.5, and that's going to turn it into litres. So 8 times 4.5 comes out as 36 litres. So now for our second option, and that one's in Wales, we get 36 litres, and that one costs £40.80. Now a couple of different methods that you can use to work this out. You can look for a common multiple of 18 and 36, so there is a nice one for this one, but for the majority of these questions you will do the cost divided by the amount, or in other words get the price per litre. So for the £22.95 we'll divide that by 18, as there are 18 litres. So £22.95 divided by 18, and that comes out as £1.275, or £1.27, £1.28. For the one on the right, in Wales, we're going to divide that by 36, as that's 36 litres. So £40.80 divided by 36 gives us £1, 13p, and there is a recurring above the 3, so just over 13p. So looking at this question, Wales is the cheaper option. So I would put here, Wales is cheaper. Read the question carefully, because this one said, Chloe thinks that petrol is cheaper in France than Wales. Is Chloe correct? You must show how you get your answer. So Wales is cheaper, so no, Chloe is not correct. And there we go, that's our final answer. So there we go, quite a tricky one there, but just getting everything into the same units just makes it a whole lot easier to actually understand and break down that question. Okay, question 6. So we're drawing a quadratic graph. Now if you have table mode, you have a calculator that allows you to do that, which you can usually get on a Casio by pressing menu 3, you can then type in this equation using the X button, which is usually alpha, and then an X, which is behind the right bracket. And you can actually just type the equation in. You can put the starting number as -2, the ending number as 4, and the steps going up in ones, and it'll just draw this table for you. But obviously not everybody has one of those calculators, so if we use the method where we just substitute the number in, we would get 4 squared, take away 2 times 4, and then plus 2. I can type that into the calculator, so 4 squared, take away 2 times 4, and then plus 2. And that comes out as 10. A good way to test this, if I put 3 in, I should get the answer 5. So just test that out, make sure you get that answer. As long as you do, you're typing it incorrectly. For this one just here, I just swap the 4s for 2s. So swap that 4 for a 2, and the one at the start, swap that for a 2, and we get the answer 2. I'm going to do the same for the 1. So just swapping the 2s for a 1, and I get the answer 1. And you can probably see there's a bit of a pattern here. You can see either side of the 1, we have a 2, and either side of that, we have a 5. We're likely going to have a 5 just here. Now double check that you get this, because when you actually sub a negative number in, you need to remember to put it into a bracket. So when I type this one in, and if I write down on the paper exactly what it's going to look like, because obviously we want to make sure we show our working out because we get marks for this, -1 squared would look like this. Then take away 2 times -1, and then plus 2. You can put this negative into brackets as well if you want to keep consistent with it, but we get the answer 5. So we know it's working because you can see over there it's also a 5. So there we go, it follows the pattern. From here we just need to plot the points. So -2 goes up to 10. We've got -1 that goes up to 5, 0 to 2, 1 to 1, 2 to 2, 3 to 5, and 4 went to 10. Now that makes a nice U shape. You need to join this up with a nice smooth curve. So obviously you're using a pencil for this, not using a ruler, because you do want it to be a nice smooth curve when you are drawing a quadratic or a cubic or a reciprocal graph. So making sure that looks nice and neat. Now the next step, you're often asked about the roots, or maybe about the turning point. You can see just here we have the turning point, and the coordinate for that is 1, 1. This isn't asking about the turning point though, it's asking about estimates to the solutions of the equation x squared minus 2x plus 2 is equal to 4. Now normally it says equal to 0, and when it's equal to 0 it's looking at the points where it crosses the x-axis. Now in this case this graph doesn't even cross the x-axis. So instead of asking equal to 0, it's asking when it's equal to 4. And where it's equal to 4 is where y is equal to 4, which is this line just here. So it's asking you to estimate this point here and this point here. We obviously already know that y is equal to 4, so it's asking what the x-coordinates are. So if you trace down from those points, you can see that there's one just here at negative 0.7, and there's one over here at positive 2.7. So our two estimates for the solution for this is negative 0.7 and 2.7. And there we go, there are the estimates to the solutions where that graph is equal to 4. Okay, on to our next question. Okay, so this says the densities of two different liquids, A and B, are in the ratio 19 to 22. The mass of 1 centimetre cubed of liquid B is 1.1. 5 centimetre cubed of liquid A is mixed with 15 centimetre cubed of liquid B to make 20 centimetre cubed of liquid C. And it wants us to work out the density of liquid C. Now whenever I have these mixture questions, I always draw a two-way table, just so I can categorise all my information and make sure it's all nice and neat. So I have density, a mass and a volume, we have liquid A, liquid B and liquid C. Fill in any information that we've got. So we know the volumes, we've got 5 centimetre cubed of A with 15 centimetre cubed of B to make 20 centimetre cubed of C. This line here is an interesting one because the mass of 1 centimetre cubed is 1.1. Now that tells us the density and it's going to help us work out the mass. If the density is written as grams per centimetre cubed, and this is telling us the grams for 1 centimetre cubed, that is actually telling us the density. So the density of B is 1.1 grams per centimetre cubed. That's going to allow us to work out the mass. Let's not forget our formula. If you use a formula triangle, density is equal to mass over volume. So to work out the mass, you do density times volume, or in other words, 1.1 multiplied by 15, which is going to tell us the mass of this part. So 1.1 times 15 on the calculator comes out 16.5. So 16.5 is the mass of B. If we can work out the mass of A as well, that's going to allow us to work out the mass of C because we know we can add the masses together. So to work out that, we've also been given a ratio. Now the ratio tells us what the densities are actually written as, or what ratio they're in. So it says A to B is in the ratio 19 to 22. B we already know, it's 1.1. So all I have to do is figure out how we've got from 22 to 1.1 and do the same to 19. Now I can do that by doing 1.1 divided by 22 and that comes out as 0.05. Oh, there we go, let's go back up. So for both of those numbers we are multiplying by 0.05. So 19 multiplied by 0.05 comes out as 0.95. So that gives me the density of liquid A. So I can write that in, 0.95. That's also going to allow me to work out the mass. Mass we already know is density times volume. So for this box just here, to work out that mass, I can do 5 multiplied by 0.95. So on the calculator, that comes out as 4.75. I can now work out the mass of C because I can add both of those masses together. So adding them together gives me 21.25, and that is the mass for C. I can then finish this question because I know density is equal to mass divided by volume. The mass is 21.25, the volume is 20. So I can type that in on my calculator and I get the density, which comes out as 1.0625, and that is the density of C. So 1.0625, and the units here were grams per centimetre cubed. And there we go, that is my density mixture question. Quite a nasty one there where you had the ratios involved as well, but hopefully once you line them up it seemed quite simple to get from B to A. Question 7. Okay, so in this question it's told us the distance between Earth and Mars was 3.9 times 10 to the 7, and in May the signal was sent from Earth to Mars. Assuming that the signal was sent travelled at a speed of 3 times 10 to the 5 kilometers per second, how long did the signal take to get to Mars? Well, our formula for speed, distance, time is speed is equal to distance divided by time. if using a formula triangle, to work out the time, which is how long it would take, we'd want to do distance divided by speed. So we want to do 3.9 times 10 to the power of 7 and divide that by 3 times 10 to the power of 5. We can just type this into a calculator. So press your fraction button, 3.9 times 10 to the power of 7, and on the bottom 3 times 10 to the power of 5. Press equals, and we get the answer 130 as our final answer. For the second part here, it says the speed of the signal sent from Earth to Mars was actually less than 3 times 10 to the power of 5. How will this affect your answer? Well, if it's not actually travelling as fast, then it's going to take longer. So we would just need to say the time will be longer. There we go, and that would be a fine explanation there. So there we go, there was a little bit of speed distance time using standard form. Question 8, it says prove algebraically that the recurring decimal 0.25 with a dot above the 5 has the value 23/90. Now for this we obviously use algebra, so x is equal to 0.25 with a dot above the 5. We can then find 10x by multiplying that by 10, when that would give us 2.55, and I've balanced it out with the same amount of decimal places, so I'll put the dot above the 5. From here you can also find 100x, and you can do it that method as well, but I tend to, when there's one recurring decimal, just times by 10 and take these away from one another. Now we know the 5s are going to cancel out, so really all we're doing is 2.5 take away 0.2. Now that's easy enough, 10x take away 1x is 9x, and 2.5 take away 0.2 is 2.3. We can then divide both sides by 9 so that we get x is equal to 2.3 divided by 9, and from here you can multiply the top and bottom by 10, which will give you 23/90. Of course there are different methods that you can use to do this. You can also find the 10x and the 100x, and when you take them away you straight away get 23/90. Completely up to you. But there we go, we've proved that using algebra. For question 9 here, it says solve this quadratic and give your solution correct to 2 decimal places. Now that gives us a massive hint that we'll be using the quadratic formula. So we need to know the quadratic formula, which is minus b plus and minus the square root of b squared minus 4ac all over 2a. The value of a is in front of x squared, so a is equal to 2. b is in front of x, so b is equal to positive 3, and c is at the end, which is negative 7. So we just need to put these values into our formula, so we'll get minus 3 plus and minus the square root of 3 squared take away 4 times 2 times negative 7, and that's all over 2 times 2. We want to type that into our calculator, and you obviously can't type in the plus and the minus at the same time, so we put in negative 3, I'll do plus to start with, the square root of 3 squared minus 4 times 2 times negative 7, all over 4. That gives me my first answer, and that answer has come out as 1.27 to 2 decimal places. The positive value, or when I've used the plus button, it fully comes out as 1.265564 and a few more decimals. Then I'm going to swap the plus for a minus, and that gives me negative 2.765564 and a few more decimals. So I would have x is equal to 1.27 and x is equal to negative 2 point, and this is 2 decimal places, so 2.77. And there we go, that is my final answer. For part B, we're being asked to expand and simplify triple brackets, and it's told us what it's going to equal. So you need to pick 2 of these brackets to start with, doesn't matter which 2, and expand those. So if I expand the first 2, 3x times x is 3x squared, 3x times positive 5 is positive 15x, negative 1 times x is negative 1x, and negative 1 times 5 is negative 5. I want to simplify these middle 2 pieces before I expand by the final bracket. So 3x squared plus 14x minus 5. I'm then going to expand that by the final bracket, which is 4x minus 3. So putting this back into a bracket and introducing the 4x minus 3. I can then just go about expanding this, but I've got 3 pieces in this first bracket. So 3x squared times 4x is 12x cubed. That's a good start because we had 12x cubed in the answer up there. 3x squared times negative 3 is negative 9x squared. Onto the 14x, 14 times 4, 56x squared, and then 14x times negative 3, we can use the calculator for this as well. 14 times 3 is 42, but minus 42x. We're now on to the negative 5. Negative 5 times 4x is going to be negative 20x, and negative 5 times negative 3 is plus 15. That's good because that matches the one in the question. We just need to make sure these pieces in the middle, so these 2x squared pieces and these 2x pieces, also simplify to what we've been asked. So double checking that, we get 12x cubed. Negative 9 add 56 is 47x squared, there we go. And negative 42 take away 20 is negative 62x. Plus 15 at the end, and that's matched what it asked us to find. So we have shown that, and there we go, there's our final answer. For our next question, we have a small question on a box plot. It says the box plot shows information about the sales in thousands of pounds of an online store each month. Alfie says 3/4 of the given data lies between 160,000 and 350,000 because these are the values of the lower quartile and the upper quartile. Alfie's wrong, explain why. Now when we are looking at the lower quartile, which is just here, which he is right, it is 160,000. And if we look at the upper quartile, he's right again because that is 350,000, but between these two quarters that is only half of the data. We have just here the highest quarter, we have down here the lowest quarter, and between the lower quartile and upper quartile we have 2 quarters worth of data, or 1/2. So Alfie is wrong because half the data is between the quartiles. So we'd say something along those lines, half of the data is between, I'm going to write LQ for lower quartile and UQ for upper quartile. So there we go, half of the data is between the lower quartile and upper quartile, not 3/4. Okay, on to the next question. Right, so we've got some indices in this. It says work out the value of a and the value of n. So ax to the power of 6 all to the power of 1 over n is equal to 7x cubed. Now if we multiply out this power in the bracket, we know we multiply powers when they're in brackets like that. A is currently to the power of 1, x is to the power of 6. So if we multiply that by 1 over n, we'd have a to the power of 1 over n and x to the power of 6 over n. And that has to equal 7x cubed. Now that makes it quite nice to see, because just here 6 over n has to be equal to this 3. 6 divided by 2 is equal to 3, so n has to be equal to 2. When n is 2, that gives us a to the power of 1/2, x to the power of 3 is equal to 7x to the power of 3. So now we need to know what is the value of a. We can put the value of n in, that was 2. Well, to the power of 1/2 means the square root. So the square root of something is got to be equal to 7. We can reverse that. If we square both sides, a must be equal to 49. So a has to be equal to 49, as the square root of 49 is 7, and that's what a power of 1/2 means. So there we go, there was dealing with some fractional indices. On to question 11. Okay, so for this question we have some graphical inequalities. So it says here on the grid, shade the region that satisfies all these inequalities and label the region R. Now we've got 3 lines to draw. Now some of these lines are quite nice ones, some of them we might have to draw a table. So for x plus y is less than 4, remember for all of these lines all we're going to do is plot the line x plus y equals 4, y is equal to x minus 1, and y is equal to 3x. Now depending on how good your understanding is of drawing straight line graphs, you may need to draw a table for these, you may not. I tend to not draw a table for these particular ones because I hope that I have a relatively good understanding of straight line graphs if I'm doing graphical inequalities. So x plus y is equal to 4 is a really nice one because that just connects 4 and 4 on the x and y axes. It's a really nice one because when x is equal to 0, y has to be equal to 4, and when y is equal to 0, x has to be equal to 4. So it's a nice one to join up. You can see there's a nice pattern between them. You can draw all of the points in if you want, or if you're very careful, you can just join up the 4 and the 4 using a ruler, but I do like to extend it all the way to the end so I can draw it nice and neat. Now when we're drawing these, you do have to look at the symbol here. If it doesn't have the extra line with the inequality, then you have to draw a dotted line. If it does have the extra ink with the inequality, you put the extra ink in the line. So nice and easy to remember. So for this one, we're going to draw a dotted line joining all of these together. Doesn't matter how long the dashes are, it just needs to be a dashed line. So I'll connect that all together, and that is my first one done. I can then move on to the next line. Now the next one, we are plotting the line y equals x minus 1. Now y equals x minus 1, that has a gradient of 1, as it's 1 in front of x, and a y-intercept of negative 1. So if I go to negative 1 on the y-axis, that's just there. Now a gradient of 1 means for every 1 across, it goes up by 1. So if I go 1 across, paying attention to the scale, and up by 1, it goes to here, then to here, and it just follows a really nice pattern going up just like the previous one. Again, that didn't have the extra symbol on the inequality, so I would draw this again with a dashed line. And there we go, that's that one completed as well. I just have one more to go. So y is equal to 3x. That's another nice one as well. Technically it's y is equal to 3x plus 0. Now that tells us that the y-intercept has got to be 0, or the origin, and the gradient is 3. So if we go to the origin, that would just be here, and a gradient of 3 means I go 1 across and 3 up. Now that actually overlaps one of the other coordinates, so let's swap to a different colour. So this is on the origin, 1 across 3 up takes us to here, 1 across 3 up again takes us to there, and then the last one we can draw going up is just there. If I follow that pattern back, so 1 to the left and 3 down, we get just to here, and I can't do any more of those points. So I just need to connect these up again using a dashed line, again using a ruler, making sure this is a nice straight line, and there we go. And just extend that all the way to the top of the grid. It's kind of hard to go beyond that when you don't fully know the pattern, but if you've got a ruler, you can normally extend these quite well. So there we go, there's our 3 inequalities. Now it wants us to label the region that these satisfy. So what we need to do is we need to pick a coordinate and see if it fits in our inequalities. We can forget about these equal to equations now, because now we are concerned about the actual inequality symbol. So if I pick one, and I normally start with picking the region right in the centre, so where it makes this sort of triangle in the middle here, I'm going to highlight this coordinate. That's the coordinate 1, 1. So if this coordinate works in all of the inequalities, I'll put my r in that region. So let's just test it out. So remember that's the coordinate x and y, where we've got 1 and 1. So in the first inequality, we have 1 plus 1 is less than 4. 2 is less than 4, so that works. For this next one, we have 1 is greater than 1 minus 1. That's 1 is greater than 0, so that works. And for the final one, 1 is less than 3 times 1, which would be 3. Or you could write 3 times 1 if you want to write it in completely. 1 is less than 3, so that works as well. So it is actually that region. That works out really nicely. It's not always the region in the middle, so do test it. Don't just put your letter in there if you get a question on this. You do need to test one of the coordinates and make sure it is actually that region. But there we go. I've labelled that region R, and that's all I had to do for that question. And there's some graphical inequalities. Question 12, we have some algebraic proof. So it says, show here that n plus 3 squared, take away n minus 3 squared, is an even number for all positive integer values of n. Now quite often in proof questions, it will ask you to use positive even numbers or odd numbers. Now we have to know that for an even number, that we would use 2n, and for an odd number, we would use either 2n plus 1 or 2n minus 1. I tend to go for 2n plus 1, but either one of those is fine. Now this isn't asking us to use the language in that particular way. It's just asking us to expand and simplify this expression. So for this one here, we've got a double bracket. You've got n plus 3 and another n plus 3, so we may as well just expand that to start with. N times n is n squared, times the 3 would be plus 3n, then 3n times n and 3 times 3 would give us another plus 3n and a plus 9. That would simplify to n squared plus 6n plus 9. The second one, pretty much the same, but we have a minus. So it's n minus 3 and another n minus 3. When we expand that, we get pretty much the same expression, but it's n squared minus 6n, and again plus 9, as it's negative 3 times negative 3. So there are two expressions, but it's asking us to take them away. So what we actually have is n squared plus 6n plus 9, and we're going to take away, and because we're taking away all three, I need to put them in a bracket. Now the reason I need to put them in a bracket is because otherwise I might forget that I'm actually taking away all three. And if I take away n squared, take away negative 6n, and take away the 9, all of the symbols in front of them are going to change. Just got to be careful because it's not quite the same as when we're collecting like terms. We're taking away all three. So n squared, take away n squared, just cancel out. So they're gone. You can actually cross those off if you want, or I'll just take a mental note of the fact that they're gone. I've also got 6n, and I'm going to take away negative 6n. And when you take away a negative, that turns into a positive. So that's going to be 12n. As well as that, I have plus 9, take away plus 9, so they're going to cancel out. So all I'm left with is 12n. Now when you are doing proof and you're trying to show that something is a multiple of something, in this case it's an even number, and an even number is always a multiple of 2, we want to try and factorise 2 out of the expression. So if 12n is our final expression, I could factorise 2 out and just write 6n on the inside. 2 lots of 6n is 12n, it means the same thing. But in this case, we can say always a multiple of 2, and therefore it's even. Therefore, even. There we go. You can write as many words as you want there, but the important part is that you get that expression correct, and just label it with a small explanation just to show that you know what you're on about. So there we go, that has proved it's always going to be an even number. On to question 13. So here we've got some inverse proportion. It says y is inversely proportional to x cubed, y is equal to 44 when x is equal to a. Show that y is 5.5 when x is 2a. Well, for inverse proportion, we know that that is the formula y is equal to k over whatever it's inversely proportional to. In this case, it's inversely proportional to x cubed. We now need to sub in the numbers that we've been given, and one of those is actually a letter. But that's not going to stop us from subbing it in, we'll just put a letter in place of x. So y is 44, so 44 is equal to k over x is a, so a cubed. From here, we can actually rearrange this to get our value of k, so multiply both sides by that denominator, which in this case is a cubed, and we get 44 a cubed is equal to k. We now know the value of k, even though it's in terms of algebra. So show that y is equal to 5.5 when x is equal to 2a. So if we put that value of k back into our formula that we'd already written, we get y is equal to 44a cubed all over x cubed. It says show that y is equal to 5.5 when x is equal to 2a. So we need to actually substitute this in and see what we get. So when we put it in, we get y is equal to 44a cubed divided by 2a, and 2a is going to get cubed. Now you've got to be careful because it's the 2 and the a which is being cubed, not just the a. So we couldn't just write 2a without the brackets, we'd have to put it in a bracket. We want to simplify that. So 44a cubed on the top, and on the bottom, 2a times 2a times 2a would be 8a cubed. That's 2 cubed and a cubed, and 2 cubed is 8. So from here, we want to simplify this. Now, first thing that stands out is the 2a cubes can both be cancelled off. The next thing we need to do is work out what 44 divided by 8 is. 44 divided by 8 is in fact 5.5. So we have shown that it equals 5.5. I haven't used the 5.5 to get there. I've just shown right at the end that my final answer comes out as 5.5, showing my steps really clearly. So there we go, there's some inverse proportion. On to question 14. Now it says here AB is a chord of the circle centre 0. The radius of the circle is 30 centimetres and angle AOB is 80 degrees. That's all shown on the diagram. Work out what percentage of the area of the circle is shaded. Now something that we can work out really easily here is the area of the circle. The area of a circle is pi r squared, and we know that the radius is 30. So I can type in pi multiplied by 30 squared, and that'll give me the area of the circle. I'm going to type that in on the calculator. Pi times 30 squared, that comes out as 2,827 0.433388. And that is the area of the circle. We now want to find the area of the shaded section. To start, we could find the area of the sector. So the area of a sector is just a fraction of the area of the circle. For 80 degrees, it's just going to be 80 out of 360. So we can take our area of the circle and just multiply that by 80 over 360, and that's going to give us the area of the sector. I'm just going to draw a picture of a sector so I know which piece is which. You can label it all with words if you want though. So on the calculator, multiply that by 80 over 360, or you could divide by 360 and then times by 80. But that gives me an area for the sector of 628.3185307. I'm just going to leave it as 3185. To get the shaded region, I would have to take away the area of the triangle from the sector. So to get the area of this triangle, I might have to use a different formula. We know the area of the triangle is half AB sine C, or base times height divided by 2, but in this case we have an angle, we've got both of the sides creating that angle, both being 30, as they're both the radius, so we can write half AB sine C and use that formula to get our area straight away. So A and B are 30, so we have half, multiplied by A, let's just put 30 in straight away, multiplied by 30, multiplied by 30, multiplied by sine of the angle, in this case that's 80. And that's going to give me the area of the triangle. So typing that into a calculator, 0.5 times 30 times 30 times sine 80. Pressing equals, that gives us an area of the triangle of 443.1634889. And just so I remember, that is the triangle. So we've got the area of pretty much everything. We've got the area of the circle, the area of the sector, and the area of the triangle. To get the area of the shaded region, I would need to take the area of the sector, subtract the area of the triangle. So 628.3185, take away 443.1634889. So typing that in, 628.3185, take away 443.1634889, gives me a shaded region of 185.1550111. Now this question said, what's the percentage of the area of the circle that's shaded? Well, as a fraction, the amount that's shaded is 185.1550111 out of the area of the circle. And the area of the circle we wrote down up here, 2,827, and the rest of those decimals. So that's out of 2,827.4333888. And when we type that in as a fraction, that will give us the decimal version. We want the percentage, so we'd have to multiply this by 100. That will turn our decimal into a percentage for us. So if I just type that in as a fraction, the answer on the top, and then 2827.4333888, and I'll put the times 100 in straight away, and that gives me a percentage of 6.548518946%. This particular question doesn't say how to round it, and if a question doesn't say how to round your answer, just don't round your answer. So there we go, it may have asked for one decimal place, it may say two significant figures. In both those cases that would have been 6.5 or 6.55 to 3 decimal places, but this one here doesn't say. So there we go, that would be our final answer. Write that on the dotted line, 6.548518946. And there we go, that's how to work out the area of a shaded region. So obviously there are lots of different shapes that you can have with shaded regions. So when you have a shaded region, you just need to work out the area of the full shape, in which this case that was the circle. But for this shaded region, it was actually inside the sector. So we had to work out the area of the sector, and then obviously take away the area of the triangle just to get that little shaded region. But there we go, on to our next one. So here we've got an enlargement by a negative scale factor. So this one is -1.5. It says to enlarge from the centre 0, 2. Now first identify that enlargement point, which is just there. From here we're going to go to one of the vertices. I'm going to go to this one, which is 4 to the right. Now you can write this using the vectors, or you can just do it by hand. I tend to just do it by hand. So that's 4 to the right. Now with a negative enlargement, we go just in the opposite direction, but also multiplying that by whatever the scale factor is, in this case 1.5. So 4 times 1.5, which you can do on your calculator, comes out as 6. So I need to go 6 to the left, so 1, 2, 3, 4, 5, 6, and that corner's going to go there. If I get rid of these lines, just so it's not all over the place, and move to the next vertice. So I'll go to this one, that's going to be 2 across, 2 up. If we times those by 1.5, they become 3. So I want to go 3 to the left and 3 down, and that ends up just here. I've got one more left to go. I tend not to guess these points or try and figure out where they go. I tend just to actually do them. So for the purple one that I've just done, that's 4 to the left and 2 up. Timesing those by 1.5, 4 will become 6, 2 will become 3. So I go 6 to the left, 3 down, and it goes just here. And there we go, that's all done. And we can connect those together. 1, 2, 3 sides, and there we go, that's been enlarged by a scale factor of negative 1.5 from the centre 0, 2. And there we go, that is a negative enlargement. Okay, so question 16, we have some algebraic fractions. Now looking at what we've got here, whenever it comes to an algebraic fraction, we want to try and factorise everything we can. We don't have huge expressions here that look like they need factorising, but we do have a pretty nasty one on the bottom of the left fraction. It says show that it can be written in the form 1 over and then x brackets x plus r, where r is an integer. So I'm going to start by just using my normal rules of fractions. In this case it's dividing, so I'm going to flip the second fraction over and multiply them, but I just want to make sure I factorise everything. Now on the bottom, this here is a difference of 2 squares. You can tell it's a difference of 2 squares because 9 and 444 are both square numbers. So hopefully you can spot this, but that is 3x plus 12 and also 3x minus 12. And that's our difference of 2 squares. So if I rewrite the first one, we have 6x to the power of 3 over 9x squared. Actually, let's write the factorised version, that's why we did it. So 3x plus 12 and 3x minus 12. And we're going to multiply that by the flipped version, or the reciprocal, of the second fraction. So that would be 2x to the power of 4 on the bottom, and 3 brackets x minus 4 on the top. Although, let's just have a look. If we did expand that, what would we get? Well, if we expand that, we actually get 3x minus 12. That's quite a nice one, because that now matches one of the brackets on my other fraction. Now when you are multiplying, you can cross cancel, because obviously everything on the top is going to be on the top, and everything on the bottom of both fractions is just going to end up on the bottom of both fractions. So we can cancel this one and this one. If there's only that on one of the fractions, that just cancels down to 1. We can also cancel from the top left and the bottom right, as both of those divide by 2x to the power of 3. They both divide by 2, and they both have an x cubed in. If we divide the 6x cubed by 2x cubed, that just becomes 3. And if we divide the bottom right by 2x cubed, that just becomes x. So there we go, everything pretty much cancels out. On the top, and if we write these out neatly, we've got 3 over 3x plus 12 multiplied by 1 over x. Now that's a lot easier now for us to multiply. So when we multiply the top, 3 times 1 would be 3, and on the bottom we'd have x multiplied by 3x plus 12. Now we've got that to a pretty simple form, but let's just have a look at what's on the top. Now it wants it in the form where there's just a 1 on the top, so it must be that the bottom can be simplified a little bit further. So if we expand this bracket to start with, we'd have 3 over 3x squared plus 12x. And you can see now that actually the top and bottom both divide by 3. So we can divide the top and bottom by 3 just to simplify it that little bit further. And once we do that, we get 1 on the top. 3x squared divided by 3 will become 1x squared, and 12x divided by 3 will become 4x. It's almost at the point that it wanted in the question, it's just that it wants us to factorise the bottom so x is on the outside of the bracket. So if we factorise that, 1 on the top, x on the outside of the bracket, x squared divided by x will be x, and 4x divided by x will be 4. so the value of r is 4. It doesn't ask us to find the value, it just wants us to write it in that form, so by doing that we have actually got the value. So there we go, there's our final answer, 1 over x brackets x plus 4. Okay, on to our next question. So this says the graph shows information about the velocity in meters per second of a parachutist t seconds after leaving a plane. Work out an estimate for the acceleration of the parachutist at t is equal to 6. Well, t equals 6 is just here, and if we trace up to the curve, that's going to take us to this point. To find the acceleration, you have to draw a tangent at that point, which is probably one of the most awkward things on the GCSE. You have to get your ruler, and you have to align it just over the top of the curve, making sure that the line that you draw goes along, just touches at that point, and then carries on off. Now, to be honest, if you actually look at mine, it's not very good because this region here is touching the curve, and just above it is actually a nice gap there. So I tend not to be able to draw these very well on the screen, but I can give it a go, and that's probably as best as I'm going to get it. You can get it really accurate when you're using a ruler. Now on a calculator paper, it doesn't really matter what the rise and the run is, because you can type them into a calculator. But I do try and like to get the run a nice number, just so it's relatively nice in terms of the calculation. So I need to draw a right angled triangle somewhere on this curve. I'm going to go from 4 to 6, wherever it crosses over, just so that my change in x is only 2. But again, it doesn't really matter when you have a calculator. It's probably better to draw the triangle a little bit bigger so that you just get a little bit more of an accurate reading. So if I draw a right angled triangle in here, up to there, and it's actually across just to there. Now that is a run, or a change in x of 2, and a change in y. I'm going to have to read it very carefully. Let's have a look. It's from there and here. Now that is 35, 6, 7, so that's 37 up to 40, 1, 2, 3, 4, 5, 6. So that's from 37 to 46, which is a rise of 9. So in terms of answering this question, when you are finding the gradient of a line, you're going to do change in y divided by the change in x, or the rise over the run. The change in y is 9, the change in x is 2, so my calculation would be 9 divided by 2, which gives me an answer of 4.5. So the acceleration is 4.5. For part B, it's asked me to work out an estimate for the distance fallen by the parachutist in the first 12 seconds after leaving the plane, and it says use 3 strips of equal width. So for the first 12 seconds is the entire graph. If it wants me to use 3 strips of equal width, I'll have to divide that by 3, and that'll be along every 4. So if I go up from 4, that forms my first shape, which is going to be a triangle. The triangle is slightly below the curve, but that's absolutely fine. As I said, we are only doing an estimate. The next one will be at 8, that forms a trapezium, and the last one will be at 12, and again that forms another trapezium. Now this is very awkward because you do have to get the heights of these correct. The triangle's a nice one, that lands on 35, so it has a height of 35. The next one is just over 50, so it looks like it's 51. You do want to get these accurate, but that is a height of 51. And the next one, I'm just going to trace across, that has a height just below that thicker line there, that's 54. So, we just need to work out the area of all these shapes. They all have a base of 4. So working out those areas, a triangle is base times height divided by 2. So 2 times 35 would be 70, and that's our area of the triangle. And for a trapezium, you have to add together the parallel sides, so 35 plus 51, divide that by 2, and times it by the distance between them, so times by 4. That'd be 172. It can help to write the working out down, because obviously we need some working out for these questions. So number 1, the triangle, I did 4 times 35 divided by 2. And then for the second one, the trapezium that we've just done, I did 35 plus 51 divided by 2 and times it by the height, or the distance between them, which was 4. For the next one, I'm going to do 51 plus 54 divide it by 2 and times it by the distance between them. So let's work that out. 51 plus 54, divide that by 2 and then times it by 4. And that gives me a distance of 210. So I have 3 distances in these 3 sections. I just need to add them together. So 70 plus 172 plus 210, that comes out as 452. So my answer is 452 metres, and there would be a small amount of allowance that you would be allowed in this question, obviously because it is quite fiddly to actually get them, but when it lands on nice whole numbers like these do, you would be expected to get that pretty accurate. It's not too difficult to just trace along, and you can obviously rest a ruler on the page just to make sure that you get the numbers perfect. But there we go, there was my answer, working out the area under the curve. On to question 18. So here it says work out the length of A to B. Give your answer correct to 3 significant figures. That's a really nice version of using the cosine rule. So nothing trying to trick you here, no triangles stuck together, just finding the length that's opposite that particular angle. So the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos A. So I call the angle that I'm looking at big A, the little side we're looking for little a. And then the other sides are b and c, and these can be written in either order. So I just need to put the numbers in. So a squared is equal to 6 squared plus 7 squared minus 2 times 6 times 7 cos 60. We can type that into the calculator. If you want, you can just put the whole thing underneath the square root, as obviously that gives us a squared. We want the value of a, so I tend to type it all underneath the square root just to save myself a bit of time. Or you can type it in and then just press square root your answer. So 6 squared plus 7 squared minus 2 times 6 times 7 times cos 60. Press equals, and that's given me an answer. That's come out as 6.557 for a few more decimals, but the question wants it to 3 significant figures, so 1, 2, 3 after the third whole number. It's a 7 afterwards, so it is going to round up. It's going to be 6.56. And there we go, my answer is in centimetres on the dotted line. So 6.56 is my answer. Okay, with this one we've got a part B. So it says here, the diagram shows the sketch or a sketch of part of the curve with equation y is equal to cos x. P is a minimum point on the curve, we can see that just down here. Write down the coordinates of P. Now if you know the sin and the cos graphs well, you'll know that they fluctuate between 1 and negative 1. So down there, we know that the y coordinate is negative 1. So up here we have the equation y equals cos x. We know the y coordinate down there is going to be negative 1, we just don't know what the x coordinate is. Of course you might know what these graphs look like, in which case you might know what the x coordinate is. But if you don't, and it's on a calculator paper, we know here that negative 1, the y coordinate, is equal to cos x. And hopefully we already know from using SOHCAHTOA, if you want to find the value there next to sin, cos or tan, you can do shift cos, shift sine or shift tan with the answer and find out what that value is. So here to find the value we'll do cos minus 1 of negative 1, and that'll tell us what x is. So typing that into the calculator, shift cos negative 1, and we get the answer 180. So the x coordinate there is 180. So to write that as a coordinate, x is 180 and y is equal to negative 1. And there we go, that's using some cosine rule and also looking at the cos graph. On to question 19. Here we have a frustum. It's made by removing a small cone from a large cone as shown in the diagram. Work out the volume of the frustum and give your answer to 3 significant figures. So when it comes to a frustum, you have to look at the scale factor between the cones. So the large cone originally had a height of 15. The little cone sitting on the top, as there's a length of 10 just here, the little cone would have a height of 5. That means that the small cone is 1/3 of the size of the large cone. So looking at the base diameter, which is 12, that would mean the base diameter of the smaller cone would be 1/3 of that, which is 4 centimetres. Obviously just dividing that by 3. So all we would need to do to work out the volume of the frustum is to work out the volume of the large cone, work out the volume of the smaller cone, and just take them away from one another. Looking at our formula, to find the volume you need the radius. So we'd have to halve these numbers, so the radius of the large cone would be 6 centimetres, and the radius of the small cone would be 2 centimetres. We can then just go about working these out. So for the large cone, we'd just use the formula 1/3 multiplied by pi multiplied by 6 squared multiplied by the height, which was 15. So just type that into your calculator. 1/3 multiplied by pi multiplied by 6 squared multiplied by 15, and that gives us 565.4866776. For the small cone, we're going to do exactly the same thing. We've got 1/3 multiplied by pi. The radius of the small cone was 2, so multiplied by 2 squared, and the height of the small cone was 5. So typing all of those in, again I'm just going to go into my calculator, I'm going to change the 6 for a 2, rather than typing it all back in, and just change the 15 for a 5. And that comes out as 20.94395102. So there we go, check you've typed that in correctly. So 1/3 times pi times 2 squared times 5, and 1/3 times pi times 6 squared times 15. So there we go, to get the volume of the frustum, we just need to take them away from one another, showing our working. So 565.4866776, take away 20.94395102. I just got to type that into the calculator as well. So 565.4866776, take away the answer, and that comes out as 544.5427266. Now it wants the answer to 3 significant figures, so we chop this after the third whole number there. There's a 5 afterwards, so that would be 545, and that's going to be centimetres cubed. So our final answer for this one is 545. And there we go, there is volume of a frustum, just using the volume of a cone formula. So question 20, we have an exponential graph. It says here is a sketch of part of the graph with y is equal to pq to the power of x, where q is greater than 0. The points 0, 5, which we can see on the graph, 2k, which we can also see on the curve there, and 4 and 405, which we can see at the top of the curve, are all on the graph of y is equal to pqx. Find the value of k. Now, with this question, usually with an exponential graph, it crosses through 1 on the y-intercept. Now this one crosses through 5. And that's why we need to have a look at that coordinate to start with. So looking at our equation, we have y is equal to pq to the power of x. Now using this coordinate, we know that the y coordinate is 5. So 5 is equal to p times q, and the x coordinate is 0. Anything to the power of 0 is 1. So that's 5 is equal to p, or p times 1. So straight away we found the value of p. So actually our equation for this is y is equal to 5q to the power of x. And that obviously starts this question off. So we're done with that coordinate. Now we can actually use this coordinate up here to figure out what that value of q is. Because we have an x and a y coordinate, so there'll only be one unknown in our equation. So if we plug those values in, y is 405, and that's equal to 5 multiplied by q to the power of 4, as the x coordinate there is 4. So solving this, we can divide by 5. If we divide both sides by 5, we get 81 is equal to q to the power of 4. So you need to do the 4th root of 81. You might already know what that is, but if you do the 4th root of both these sides, which you can do on your calculator, you get that q has to be equal to 3. We obviously now know the values of p and q, so we know the full equation. We now know that y will be equal to, p was 5, and that's going to be multiplied by 3 to the power of x. This is going to allow us now to find the value of k. So here we have the x coordinate, we just don't have the y coordinate. So if x is 2, y is going to be equal to 5 multiplied by 3 to the power of 2. 3 to the power of 2 is 9, so y is equal to 5 times 9, which is 45. Now obviously y here is the y coordinate, and k is in the position of the y coordinate, so if y is equal to 45, that's told us the value of k. So k is equal to 45. So our final answer there is 45. So there we go, there was a bit of a problem using an exponential graph, and there we go, always focusing on this particular coordinate here to start with. Okay, on to our next question. So here we've got some completing the square. We also have a coefficient of x squared higher than 1. So this is one of the harder versions. If that coefficient isn't there, it's much easier. But if it is there, all you have to do is factorise that coefficient out to start with. So we'll take 2 out of the brackets. We then get 2 lots of x squared plus 8x, and 35 divided by 2, you can obviously do that on the calculator, is 17.5. So that's the quadratic we get when we factorise out 2. We can now just complete the square as normal for the quadratic there that's inside the bracket. So when completing the square, we halve this coefficient of x, we get x plus 4 in brackets squared, and if we were to expand that, the number that you would get at the end would be plus 16. We don't want plus 16, we want plus 17, so I would have to add 1.5 to that. 16 plus 1.5 would balance it back out, so all of that, if you expand and simplify it, comes out as x squared plus 8x plus 17.5. Now you have to remember as well, we did actually have that 2. So on the outside of all of this, we still have this 2, and we do want to bring that back in. If we multiply everything there by 2, you don't need to multiply what's in the brackets by 2, you can just put 2 on the outside. So it would be 2 lots of x plus 4 in brackets squared, but the 1.5 is going to be multiplied by 2, and that would become 3. That there is now written in completed square form, where a, b and c are integers. It also says here, hence or otherwise, write down the coordinates of the turning point of the graph. So for this particular graph, the turning point is within the brackets, the x coordinate is the number in the bracket, but change the sign, so plus 4 becomes negative 4, and the y coordinate is the number at the end, so just 3. So there we go, that is the coordinate of the turning point. That 2 on the outside doesn't affect the x or the y coordinate when reading it. So obviously if you don't have a coefficient of x squared higher than 1, this is a much easier question because you can obviously just go from that first part and not worry about refactoring in that 2. So there we go, that was a completing the square question with a turning point where you had a coefficient of x squared higher than 1. On to our next question. It says here is a circle centre 0. And the tangent to the circle at the point 4, 3. Find an equation of the tangent at the point P. Now finding the equation of a tangent isn't actually too bad. We've got the coordinate 0, 0 at the centre and the coordinate P. And if we find the gradient of the radius, we know that a tangent is at 90 degrees to the radius. So we can find the negative reciprocal of that and then just plug it into y equals mx plus c. It is a relatively long process, but once you've got your head around these, they're not too bad. So the change in y divided by the change in x will give us the gradient. So the change in y goes from 0 to 3. So that's 3 on the top. The change in x goes from 0 to 4. So the gradient of the radius is 3/4. That means the negative reciprocal will be negative 4 over 3. Just flipping that fraction over and changing the sign. You can also see that the tangent has a negative gradient, so it would make sense. If we put that into y equals mx plus c, we get y equals negative 4 over 3x plus c. All we need to do at this point is substitute a coordinate that's on that line into x and y, and we'll get our value of c. So obviously this is the coordinate we've been given, 4 and 3. So y is 3 and x is 4. So 3 is equal to negative 4 over 3 multiplied by the 4 and then add c. You can now expand that. Remember that negative 4 over 3 multiplied by 4, you can just do on the calculator. But 3 is equal to negative 16 over 3 plus c, and we just need to add 16 over 3 to both sides, and again remembering you can always do that on the calculator. So if I work that out on the calculator, 3 plus 16 over 3, that gives me 25 over 3. So 25 over 3 is equal to c. I've now got all the pieces, I just need to put them all back in the right place, because this value of c here I need at the end of my equation. So if I put that into the right position, I get y is equal to minus 4/3 x plus 25 over 3. And there we go, that's the equation of the tangent. Sometimes you can also be asked to write these in a certain form. For example, it's quite often that we don't want fractions written in our equations when we write them, as it's easier to write them in linear form. If you are asked to do something like that, you just have to multiply everything by 3 and it would get rid of the fractions. This question doesn't, but if we were asked, it wouldn't be wrong to write this in anyway. So 3y would equal negative 4x plus 25. And you might even be asked to rearrange that and move pieces around. So you could add the 4x to the other side, minus the 25, you could write it equal to 0, you could leave the 25 where it is. You obviously just need to read the question and see how you've been asked to write it. As we've not been asked to do any of that, we'll just leave it in its y equals form. So y equals minus 4 over 3, 4 over 3x, let's just write that again, I've not written it properly, minus 4 over 3x plus 25 over 3. There we go, absolutely fine to leave your answer in fractional form like that. Okay, and on to this question 23. Solve algebraically the simultaneous equations. So we have 2x squared minus y squared is equal to 17, and x plus 2y is equal to 1. Now that 2 on the x squared there is going to make this pretty tricky, unless we can make the second equation y equals without then incorporating fractions. So there's two ways that I could rearrange this. I could make it x equals by minusing 2y to the other side, so 1 minus 2y, and sub that in place of x. I could also make it y equals. I'd have to do that in 2 steps. I'd get 2y is equal to 1 minus x, and then I'd have to divide by 2, so I'd get y is equal to 1 minus x, all divided by 2, and I could sub that in place of y. Looking at the 2, it looks like it's easier to sub the x value in. So I'm going to get rid of all of these. I'm going to sub x in place of x. So 1 minus 2y is going to go where x is. So I've got 2 lots of 1 minus 2y. That's being squared. Then minus y squared is equal to 17. That's now eliminated any x's from the equation. I just need to expand and simplify all of this really carefully, make it equal 0, factorise and solve it. Obviously a lot of steps, but this is a quadratic simultaneous equation. So I've got 2 lots of, and if I expand 1 minus 2y, I'll probably do that to the side. So 1 minus 2y, and another 1 minus 2y. And if we expand that, 1 times 1 is 1, 1 times minus 2y is minus 2y, minus 2y times 1 is minus 2y, and minus 2y times minus 2y is plus 4y squared. If I tidy that up and write the 4y squared first, you get 4y squared minus 4y plus 1. So I have 2 lots of 4y squared minus 4y plus 1 minus y squared is equal to 17. I can now expand that bracket, so that would give me 8y squared minus 8y plus 2 minus another y squared is equal to 17. There's a lot of steps here just tidying it up. I've got an 8y squared and a minus y squared, so I could simplify those two. So these I can simplify. So 8y squared minus 1y squared would be 7y squared. So 7y squared minus 8y plus 2 is all equal to 17. I now just need to see if I can actually solve this relatively easily, or whether maybe I have to use the quadratic formula. Hopefully we can actually factorise it. So when you come across one of these questions, if you are not very quick at factorising, it probably is best just to stick it into the quadratic formula. Now obviously remember, when you have to factorise, it does need to equal 0. So we need to minus 17 from both sides. So I'd have 7y squared minus 8y, 2 minus 17 is minus 15, and that now equals 0. Now the good thing about this, if it does factorise, it's going to have to be 7y and 1y. They're the only two options that would give us a 7y squared. The factors of 15 are either 1 and 15 or 3 and 5, so not too many options. I want to make negative 8 in the middle. One of these factors though is going to get multiplied by 7, and that's quite clear actually, because it's going to be 1 and 15. 1 multiplied by 7, taken away from 15, or 15 taken away from 7, is going to give us 8 or negative 8. So I want the 1 to be multiplied by 7, I'd stick that in the right bracket, and the 15 to stay as it is. I'm trying to get negative 8, so I want to have negative 15 plus the 7, and there's my factorised version. The solution for the left bracket is going to be positive 15 over 7, and the solution for the right bracket is going to be negative 1. Remember just flipping the symbols there. So there's my two values of y. But they can easily be subbed back into one of the equations as we have a calculator. So up here originally we worked out that x is equal to 1 minus 2y. So if I write them just down here, x is equal to 1 minus 2y, I just use my calculator to sub those back in. So here x will be equal to 1 take away 2 lots of 15 over 7. And if I just type that in the calculator, so 1 take away 2 lots of 15 over 7, and that comes out as x is equal to negative 23 over 7. For the next one, you've got x is equal to 1 take away 2 lots of negative 1, or 2 times the minus 1. I can type that into my calculator, 1 take away 2 lots of negative 1, and that gives me x is equal to 3. So these obviously come in pairs, as they are coordinates. So for this particular set of solutions, we get x is equal to 3, and y is equal to negative 1. And for this particular set here, we get minus x is equal to minus 23 over 7, and y is equal to 15 over 7. And there we go, there's our solutions for this pair of quadratic simultaneous equations. Obviously a lot of working there, but most of it is just sort of tidying things up and making sure you're really confident with expanding brackets, factorising and solving quadratics. Okay, on to what I believe is going to be our last question. Okay, so this question says PQRST is a regular pentagon. RU and T are points on a circle centre 0. QR and PT are tangents to the circle, and RSU is a straight line. Prove that ST is equal to UT. So ST is this one here. It wants us to prove that that's equal to this one. Now if those two sides are equal, then that triangle just here would have to be an isosceles triangle. So let's have a look at seeing if we can prove if that's an isosceles. Now first things first, it says that it's a regular pentagon. So if we want to work out the interior angle of a regular pentagon, we would take away 2 from the amount of sides, which would equal 3. That's therefore made up of 3 triangles. 3 times 180 is 540, and dividing that by 5, each angle is 108 degrees. Now if we label that on the diagram, this would be 108, this would be 108, this over here would be 108, and those 2 top angles there would be 108. But it also tells us that we have some tangents to the circle. So QR is a tangent, and if we draw a line to the radius, draw the radius to the centre, that would create a right angle. And if we draw another line to that point on the tangent, we also create another right angle. And obviously that information is going to be important, so we may as well just put those in to start with, as that's given to us in the question. So it tells us it's a pentagon. We've dealt with that. We've got the angles in the pentagon. It tells us that they're tangents. We've dealt with that. We've put the right angles in. What else does it tell us? It tells us that RSU is a straight line. So if this is a straight line here, you can see that we have angles on a straight line, this 108 and the one next to it. So next to that 108, 180, take away 108 would give us 72. So that one there has to be 72. So moving on to the next part then, where can we go from here? Well, we've got one of the angles, so if this is an isosceles triangle, which is obviously what we're trying to prove, then we need to find either this angle or this angle. And it looks like it's going to be the angle over by U. So how can we try and get that angle? Well, we have got a circle, and so far we haven't used any sort of circle theorems. But from T to U, that makes that angle, and from R to U, it makes an angle at the circumference. And from T to O, the centre, and R to O, it also makes an angle at the centre. And we know that angles at the centre are double angles at the circumference. So if we can find this angle here, we'll be able to halve that to find this angle here. And if it's 72, we've proved that it's an isosceles, and therefore ST will have to equal UT. So looking at this then. Now over here we have another pentagon that we've kind of created. We've got 3 sides just there of the regular pentagon, and then we've got 2 additional sides that we've added in here by adding in those radiuses. So if we go about trying to figure that out, we know that the angles in a pentagon add up to 540 because we've just worked it out. So if we add up the 4 angles in there, we've got 2 90-degree angles, so 90 plus 90 is 180. We've got 2 108s, so 108 plus 108, which is equal to 216. If we add those together, we get 396. We know that the angles in a pentagon add up to 540, so take those away. 540 take away 396 is equal to 144. So that missing angle here at the centre is 144 degrees. Angles at the centre are double angles at the circumference, so if we halve that, 144 divided by 2 gives us the angle 72. So this angle here is also 72. Therefore, that triangle there is an isosceles triangle, as base angles and isosceles are equal, and if the base angles are just there, then ST and UT would be the two equal sides. Now it has asked us to prove this. We have kind of proved it, but we should probably have given some reasons along the way. So just here, we would also want to say tangent meets a radius at 90 degrees. Over here, the reason we divided by 2, angles at the centre are double angles at the circumference. And there we go, are double angles at the circumference. And what else did we use? We also used here, angles on a straight line are equal to 180, so we could add that in as well. I'm not going to draw all over this because I want it to be nice and clear for you to see, but we'd add in any reasons there that backed up our proof. Obviously we need to make a conclusion here, so we have that, let's see what the angle's called, TSU. TSU is equal to TUS, as they are both equal to 72 degrees. We would say that base angles in an isosceles are equal. In an isosceles are equal, and therefore ST is equal to UT. And there we go, and that would be our proof for that one. So there we go, that was an unusual geometric proof that also involved angles in polygons, some circle theorems, and also angles in a triangle. So quite an interesting one, definitely a question that I like. But there we go, that was the last question on the paper. Okay, well done for making it to the end of the video. That is the end of that paper, and hopefully that was useful and helpful. Obviously don't forget that I have posted previous videos going over one question on every topic within here. So obviously anything you struggled on within this paper, make sure you go and practice it. And anything that we haven't covered in this one, do make sure you check it out in the other video as well, just to make sure that you get a full coverage of all of the topics that haven't yet appeared. Okay, obviously the next video is going to be the night before the exam, where I'll be doing a revise along with me, so make sure you check that out as well, and hopefully I'll see you in that one. Okay, so that is the end of this video, and I'll see you for the next one.